Hi everyone, welcome to lesson 4. Now we will talk about zero-knowledge proof technology. This video is based on 3 articles from the official website. You can learn more on your own. The article How Zero Knowledge is Rebalancing the Scales of the Internet presents the concept of the technology. In the article The Future of Zero Knowledge with Aleo, you can explore the capabilities of Aleo and the tools they offer. The third article, called Zero Knowledge Primitives by Aleo, introduces the primitives that underlie the Leo programming language. As we discussed in lesson 2, the business model of the web is to provide free services in exchange for personal data. Zero Knowledge Proof technology changes this. The state of the internet of today is a few monopolies that collect vast amounts of data yet fail to deliver a personalized user experience. But how can we expect to fix this without being even more liberal with the data we share? The good news is that there is a solution that does allow us to achieve both a more private and more personalized web experience: zero-knowledge proofs. We have already said that a zero-knowledge proof is a cryptographic protocol where one party, the prover, proves to another party, the verifier, that something is true without revealing how it's true. Though public blockchains have provided immense financial access, the fact that transactions are transparent and open for all to see leaves opportunities for exploitation and arbitrage. Until now, users have had to choose between the two: privacy or programmability. For example, Zcash gives users complete privacy but limited programmability. Ethereum provides powerful programmability but limited privacy. Aleo solves this problem. Through opt-out privacy by default, Aleo enables a sustainable, equitable Web3 world that can meet developer, consumer, and enterprise needs. Zero-knowledge cryptography and zero-knowledge proofs allow third parties to verify the truth of a piece of information without us needing to reveal it directly. Aleo uses this as the foundation of a system called ZEXE, Zero-Knowledge Execution. In ZEX, users execute state transitions offline. This process produces a proof which is bundled into an on-chain transaction. This transaction updates the state of the system by creating on-chain records. Like Zcash, this system gives us strong privacy guarantees, as the transactions contain only the proof, not the input that generated it. And like Ethereum, ZEX can support smart contracts that enable users to interact or transfer value in a predefined way. Every application on a decentralized network is a series of users, people of smart contracts, transacting with one another in varying degrees of complexity. Any privacy solution therefore has to ensure both those atomic components of any application are private. For example, let's say you want to trade token A for token B on a Aleo-based DEX. First, you will need to prove to the DEX that you have enough of token A in your possession to complete the transaction. But because this information can be shown through a zero-knowledge proof, this does not mean revealing your valid balance or trade history. Instead, you can reference an on-chain proof of a prior transaction to show that you have a sufficient balance to trade. In the process, the exchange never learns the amount of tokens you own, where you got those tokens from, if you have ever transacted on the DEX before. Altogether, this creates a DEX ecosystem that is not only entirely private and scalable for users, but also replicates a key feature of smart contracts blockchains like Ethereum: composability. Zero-knowledge primitives. A primitive is a basic building block of a programming language, an atomic unit that is not divisible into smaller components. Applied to a high system level, primitives can also be thought of as ingredients which can be combined in many ways to make different recipes. They are a first principles approach to emerging technologies, representing the core components of any solution that can be combined and iterated to create novel solutions. So what are the primitives of zero-knowledge applications? Shielded identities are like a firewall which protects the private information of a given person or entity. Sharded identities are like the cryptographically based driver's license that hides all irrelevant information from the questionnaire. Shielded identities allow individual smart contracts, DAOs, and enterprises to interact with one another without revealing any information beyond what precisely needs to be known. Shielded transactions are a primitive first created by Zcash, but shielded transactions in Aleo are more than just asset transfers. They describe all kinds of interactions with another person of program. Some examples beyond simple payments include liquidity provisioning, voting in governance, identity authentication, decentralized notifications, and more. Because only the interacting parties know the details of a transaction, malicious third parties cannot learn the details of that interaction or exploit it in any way. Shielded identities describe the individual, and shielded transactions are the means by which they interact. In Aleo, they do so off-chain in an environment called ZK Cloud, a component of the Aleo stack that forms the basis for a more secure, private, and personalized paradigm for applications. ZK Cloud describes a model of peer-to-peer decentralized private computing in which shielded identities interact, either directly or programmatically. By moving this interaction off-chain, we not only guarantee privacy, but also enable greater transaction throughput. Shielded transactions link the interactions of one or more parties within ZK Cloud to the Aleo blockchain. These transactions contain cryptographic proofs that those interactions were valid, yet by default they do not disclose what program was executed or who participated. The Aleo blockchain stores records of these transactions, which can be referenced to determine the global state of an application at any given time. ZK Cloud applications can be run locally on a user's machine or delegated to a third-party proving service that constructs proofs and submits transactions on behalf of users. This makes a broader range of applications practical on Aleo today and opens up the door for a new marketplace for delegated private computation. Thanks for watching, and I'll see you in the next lesson.